Okay, we're starting this activity. This was a tough one. This was March 22nd and 23rd. So up at the very top, I think you can figure this out. In order to figure out how many heartbeats in 10 seconds, you count the R waves. So you just go boom, boom, boom. There's 12. How do you figure out in 1 minute? So multiply by 6. Why 6? Because it is 10 seconds. 10 times 6 is generally 60 seconds. Okay. So as we go down, you already know how to label a PQRST. It was in your homework, and we did an activity on it. We did the EKG lab. So if you still don't know what any of the things are, there's a little explanation right here. If you don't know what contraction, systole, depolarization, all of the words are right there. So first thing here, it says, label PQRST, there it is. What cardiac happens during the P wave? Now you got to remember, the P wave is where the atria depolarize. Depolarize means that it contracts. What happens during the QRS? The ventricles depolarize, which is great, but also it's two things. The atria repolarize. Repolarize means relax. All right, so keep that in mind. Repolarize, relax. What cardiac events happen during the T wave? Now, this is ventricle repolarization, but you got to remember, that's when we did the squeezing. So when you have a turkey baster and you squeeze it, that would be right here, the squeezing. And when you let go, it sucks in. So this is when the heart fills. I do bring that up over and over again because you got to remember, your atria don't do the heart filling. The suction is what fills the heart. Okay, I'm going to go down because we got to get through this kind of quickly. So this part right here is the ventricle filling and emptying. So why are we doing this? Because going down all the way down to this graph right here, where is it? It's right here. Oh, right here. This graph is really hard, so I'm taking it one step at a time. So right here, we're going to do this particular line right now. So you know that when your heart beats, it's never completely empty of blood. So right here, it's 130. This is 50. So that means it doesn't pump out all 130 milliliters of blood. There's still some residual blood left in your heart, kind of like there's residual air left in your lungs because the air it's just kind of stuck in there. All right, so maximum is 130. Okay, this is called the end diastolic volume. Is that important? Kind of, because we're going to use it over and over and over again. Minimum amount is 50. So to figure out the stroke volume, how much is actually pumped out? So right here, this is how much blood is actually pumped out of your heart. So 130 minus 50 equals 80 milliliters. So that would be your stroke volume. All right, when the left ventricle contracts, is it completely empty? And I just talked about that. We need to figure out the ejection fraction. The ejection fraction is of the amount of blood that's in the heart, what percentage is pumped out? Why is it called a fraction if you want a percent? Don't know. All right, wish I could tell you, I don't know. So we take the stroke volume, which we figured out right there, so 80, and then we're gonna divide it by EDV. That means how much blood total that your heart holds. So we could look up here, but we also wrote it right there. So 80 divided by 130 equals, I believe, 61.5%, all right? So it came out to 0.615, which means multiply by 100 to get your percent. So if the heart's been damaged, your heart would be like barely beating. So this is going to go way down, all right? And then if you're doing aerobic training, then it would go way up. So I need you to think about people that are in peak physical condition. Their heart is beating super efficiently.